scientific hypotheses and theories. A scientific hypothesis is an educated guess based on observations about why something happens or what will happen next. So it's sort of an explanation about why something is happening, or a guess about what will happen next based on observations. And they're often given in an if-then format, where you would say something like, if I drop this egg on the floor, then it will crack open and break. If I drop this rubber ball on the floor, it will bounce back up. So you've got your if this happens, then this other event will happen. And it's a hypothesis because you don't know that it'll happen every time. So hypotheses must be falsifiable. And what that means is that it's able to be proven false. So, in order to be proven false, it must also be testable. And those tests must be able to be replicated. So, over and over again, you will test a hypothesis. You will figure out a test for it. You will say, if I drop this rubber ball, it will bounce back up. Well, you can test that theory, you can test that hypothesis over and over again by dropping the ball and seeing if it actually bounces up. Or with the egg, you could say, if I drop this egg, then it is going to crack and break. You could try dropping an egg over and over again and test that hypothesis. And it must be able to be proven false. So if even one time you drop an egg and it doesn't break and crack, then your hypothesis has been proved false. And you must come up with a new hypothesis. The same thing with your bouncy ball. If you drop the rubber ball and even one time it doesn't bounce, it just kind of falls and rolls, then your hypothesis has been proven false. Now, a hypothesis can be rejected. So you can say, this doesn't work at all. I need to come up with a new explanation for why this is happening or what's going to happen next. Or they can be modified. You could change yours to, if I throw this egg on the floor, it's going to break. Then that may be something you could test over and over and see if it is ever proven false. But it can never be proven true. A hypothesis can never be proven true. So you can test your hypothesis 1,000,000 times, but you can never prove it true. Your hypothesis may be true every time that you test it, but there's always a possibility that there's one more situation out there that you haven't tried yet, and if you tested your hypothesis in that situation, it could be proven true, or it could be proven false. So you can't prove one true. There's always that possibility that it's false. So if you threw your egg on the floor 1,000 times and every time it broke, there could still be one egg with a really hard shell out there that even if you threw it and it landed just right, it didn't actually break. And that one time would prove your hypothesis false, so you can never really prove a hypothesis true. Now, hypotheses may be favored due to falsifiability, which is its testability, its ability to be proven true, well, its ability to be proven false, because you can't prove it true. But if a hypothesis isn't testable at all, if you just say, I think this will happen, but there's no way to test it, then it can't be a good hypothesis. You have to be able to test your hypothesis. If you say, I think this egg will float if I take it onto Neptune, well, that's not really something you can test, so it's not a good hypothesis right now. But if you say, I think that this egg will break if I throw it on the floor, that's a testable hypothesis, so it has good falsifiability. Next is simplicity. Does your hypothesis make sense, or is it too far-fetched? You don't want something that is really far out there. If I throw this egg on the floor, it's going to turn into scrambled eggs. very unlikely, doesn't make a lot of sense, and so that's not a simple explanation for something. It's not a simple hypothesis. You need one that's going to be making the most sense, or the most likely scenario as you see it. Now, you may not know, but you need to make an educated guess, one that would be very realistic and not one that would be too far-fetched. And it can also be favored due to scope, or applying to the widest range of phenomena, or the widest range of situations. If the hypothesis is only good in a very specific certain situation, then it's not going to be a very good hypothesis, because it will be easily proven false if it's only good in that one situation. You want a hypothesis that will apply and be tested, and have the hypothesis tested as accurate over the widest range of scenarios. If it's only good in one situation, it's going to be proven false quickly. If it's good in a lot of situations, then it may not be proven false, and your hypothesis can continue being considered a good hypothesis. Now, if your hypothesis is tested over and over and over again, and it becomes widely accepted as a good hypothesis, is something that is almost true, then it can become a theory. And a scientific theory is a hypothesis or group of hypotheses that have been supported with repeated testing and have not been proven false. So, these hypotheses have been tested over and over and over, and lots of people know about them. Lots of people widely accept these theories, and since it's widely accepted, it's considered a theory. And since it hasn't been proven false yet, it can be considered a theory. A theory is basically an accepted hypothesis. So this is accepted by most people as the most logical explanation for a situation or an event, or the most logical explanation of what will happen if something else happens. And a theory can be proven false. If a theory is ever proven false, then it is no longer a theory, and new hypotheses must be introduced. So you test your hypotheses. If it's proven false, or if they're proven false, then you need to reject them completely or modify them to see if you can come up with a good hypothesis. If your hypothesis is tested over and over and over and becomes widely accepted among a lot of people, then it can be considered a scientific theory. And if your theory is ever proven false, even one time, then it's no longer a theory, it's a bad hypothesis, and you have to come up with new hypotheses. And that can either be by modifying that first one, or rejecting it completely and coming up with a new explanation.